Hello, guys. Welcome to Ramta Solutions. Welcome to your Great Term Physical Sciences. And today, in your fundamental topic, Skills for Science, we are looking at scientific notation. So, you guys must have seen, or if you have not seen this, I want you to imagine there are some numbers that are way too big. I mean, imagine working with a number that is like 10 to 15 digits. That number is too big. So when we write this number, including myself, I get tired of writing such numbers. They're boring. And some numbers, they are so small. Say you have 0,0000. I don't know how many numbers until maybe 17 decimal places. Nobody likes to work with that, right? And because we are scientists, we always find a way to simplify our everyday life, right? So So that simplification has been the introduction of scientific notation, and which we say it is a compact way. It is a compact way of writing very big or very small numbers. So the general form of your scientific notation is this: capital N times 10 to the power n. Do not, you don't need to know this general form, but it's just a way of saying, they are like this. So normally what we say about this general form, this n, perhaps let me change the color. This n will basically be, uh, should I say a decimal? Perhaps let's call it a decimal, which will be between 0 and 10. Okay, it'll be between 0 and 10. Okay, so okay, but calling it a decimal may not really be correct because I think it's fine to say, let's call it a decimal between 0 and 10. Okay, it'll be a decimal between 0 and 10. It's fine to call it like that. Okay, it's fine to call it like that. It'll be a decimal between 0 and 10. You're going to see that. Okay, you're going to see that. And then this n, this small n, will be the number of times a decimal has been moved. Okay. And by the way, don't be surprised. I have a calculator here which I have hidden. You're going to see to use it shortly. Number of times a decimal has been moved. Number of times a decimal has been moved. Number of times a decimal. Uh, number of times a decimal has been moved. Right? Number of times that a decimal has been moved. Okay. So if you move to the left, n is positive. If you move to the right, n is negative. Okay, if you move to the left, n is positive. If you move to the right, n is negative. You are going to see that just now. Okay, so if you move to the right, n is negative, and if you move into the left, n is positive. Okay, you're going to see that just now. Right. So without any waste of time, let's get into it, and we're gonna show you what we made. So now let us say now write the following in scientific notation, and we're going to confirm using a calculator as well. Write the following in scientific notation. They are: number one, 6,782,498. Number two, it'll be 0,0007894. Okay, so oops, and I need to add this. Yeah, let me do this. Let me add this. I should say quarter to two decimal places. Write this in scientific notation. Correct to 2 decimal places. Correct to 2 decimal places. Okay, correct to 2 decimal places. Sorry, I'm squeezing it, guys. Correct to 2 decimal places. Now let's get our solution. So our solution. Now, number one, we are saying we have 6,782,498. So when we say we are writing it in scientific notation, if you do not have a calculator, this is what you're going to do. So check this out. I'm going to use a green color here. This is basically the comma, right? Where your decimals are beginning, because here it's comma 0000, but we don't have that. So as you can see, for this particular number from this comma, right, you agree? Okay, let me write it here. Let me write it here. This is the same as 6782498 comma 00 blah blah. Right? So now there's no need to move to the right. So we have to move to the left. Now let me use my green color. So here, let's see. It's one place, second place, third place, fourth place, fifth place, sixth place. Remember, correct to 2 decimal places. So we can say, oh, if this is the case, we can say we have moved how many places? 1, 2, 3, 4, 5, 6. So this means this number must be 10 to the 6, isn't it? It must be 10 to the 6. However, we stop here. Our comma is no longer here, but rather here. So this then becomes 6 comma, hold on. This will be the 2 decimal places that we are looking at. The third one was 2. So since the third one was 2, it means the second will remain unchanged. So this becomes 6,78 times 10 to the 6. Okay, 6,78 times 10 to the 6. If you like, before we round off, if you like, you can say this is 6,782,498 times 10 to the 6. But because we are rounding off to 2 decimal places, we will say this is 6 comma, we said the third place is 2, so this means the second will remain unchanged. 6,78 times 10 to the 6. Now let's take our calculator and confirm. So you guys are using Casio, right? You guys are using Casio. Now let's see. This is our Casio. Let's see now. So we have. I'm gonna try it with this one first. 6 comma. Let's see if it's gonna give us this number here. Okay. So this is 6 comma 7 8 2 4 9 8 times 10 to the 6. See, when you want to write times 10 to the, this is a times 10 to the 6. Let's see what it gives us. Indeed, it gives us 6,782,492. Okay, this is what it gives us, right? Perfect. All right, so we're hiding it. Obviously, guys, even if we say 6,78, it'll still be correct. All right, now let's try number 2. Number 2 was 0,0007894. So what do we need to do here? 0,0007894. What do we need to do now? We need to move. We are not moving to the left. We're moving to the right. So it means the power will be negative. Let's see. We move. Pedi, taro, nne, tlhano. Right? So 1, let's see, 1, 2, 3, 4, 5. Right? So this means this number must be 10. Oops. It must be 10 to the power. We said we moved how many decimal places? 5 decimal places. And we have moved to the right. So it will be negative power. So 5 places. Okay. So what is this? This is 7,894. Okay. Right. This is 7,894 times 10 to the negative 5. But remember, we said we are rounding off to 2 decimal places. So rounding off to 2 decimal places, the third decimal place is 4. So since it is 4, it means the second will remain unchanged. So this is 7.89 times 10 to the negative 5. Right? And this is how we perform scientific notation. Now let's confirm. Now let's confirm. When we confirm, we are going to say, okay, let's clear this AC. So we have 7,894 times, right? Negative, do you see this? Negative 5. All right? And then equal to. What do we get? Are we not getting the very same thing? Look at it. 0, 1, 2, 3, 4. 4 zeros. 7,894. Indeed, it is what we got. Okay. Indeed, it is what we got. Okay. Indeed, it is what we got. All right. So remember, guys, sometimes you can, if you're not working with um, 2 decimal places, you can get to the power -6, -7, -8, -9. It'll still give you the same answer. But this we will do in one of the shorts that we're going to be having shortly. Okay. So this is it, guys. This is how you perform your scientific notation. Okay. This is how you perform your scientific notation. And I think, yeah, to not make this video long, I think I'm gonna leave it here. But maybe let me just add in passing. If you were not restricted to 2 decimal places, you would still call this, I'm gonna change the color. You can still say this is, for example, let's see. When you move one place, it'll be 6, 7, 8, 2, 4, 9, 8 times 10 to the, now you're moving one place. When you move one place, it'll be times 10 to the 1. And then you're moving 2 places now to the right, right? You're moving 2 places to the right. What am I doing now? So you moved one place. So when you move 2 places to the left, sorry, 6, 7, 8, 2, 4, 9, 8. When you move 2 places to the left, it'll be times 10 to the 2. So here is your comma. When you move 3 places, 6, 7, 8, 2, 4, 9, 8. We say 30 places to the left, it'll be 6, 7, 8, 2. Again, if you move whatever number of places. So you see, all of them are going to give you the very same answer. Okay? They are the same. They are the same, guys. They are the same. If you move 4 places to the left, 1, 2, 3, 4. So here is it. Again, if you move 5, just like that, this is how it is. Okay? This is how it is. Okay? Similarly, with this one, you can move many places. So now we're going to try 6 places to the left. When you say 6 places to the left, it'll be, let's see, 6, it'll be, let's see now. Already this is 5 and 6 will be here. It'll be 78.94, isn't it? This will be the 5th, this will be the 6th, this will be the 7th, this will be the 8th. All right. Now let's move 8th. It'll be 789.4 times 10 to the 7. Now let's move 8 places. 8 places. It'll be 7,894. Oops, there's no comma. 7,894 times 10 to the negative 8. If you press this on your calculator, it'll give you this. In fact, if you press any of them, it'll give you exactly this. Okay, it'll give you exactly this. And this is how you perform your scientific notation without a calculator. All right, guys? So this is it. See you next time and bye bye.